Code 8. String to integer. A toy in JavaScript. This one uses regular expressions. And we have a lot of downvotes on this one. It's a bad sign. The reason we have a lot of downvotes is the exact reason I'm going to explain this. And that is that people are not reading their crappy description. They're jumping down to the examples, which you always have to do in LeetCode because their English sucks. They don't write things. They don't proofread, just like they have lots of bugs on their website. Because they're kind of dumb in a lot of ways. They're probably good at algorithms, but that boosts their ego, and they don't see what's wrong with them. They don't work on their weaknesses. So don't let LeetCode be a model for your behavior. And here's an example right here. We got the input is this, the output is -42. That's wrong, okay? Expected output is 0. Right, the expected output is 0 from that. The requirements don't cover this scenario. Yes, they do. They absolutely do, okay? So you have to really understand this description. I'll make some minor corrections to their description, which isn't that bad. Implement the myAtoy string s function, which converts a string to a 32-bit signed integer, similar to C++'s a toy function. The algorithm is as follows. Read in and ignore any leading white space. Key bullet point. Check if the next character, if not already at the end, is plus or minus. Read it in if it is either. This determines if the result is negative or positive, respectively. If neither is present, assume it is positive. Read in the next characters until the next non-digit character at the end of the input is reached. Okay, so we're looking for plus or minus. Now we're looking for any non-digit character or the end of the input is reached. Non-digit character. Okay, so anything that's not 0 to 9. Okay, so we got to read things in until we get something that's not 0 to 9. Okay, so we start out, we look for any leading white space, and we'll get into the detail on that. It means they want U0020. That's the space character. Memorize that. That's the space character. White space definitions vary between languages and implementations. Different JavaScript implementations have different definitions of white space. It's messy. There is even the Hangul character, which is invisible and can actually function as an identifier in JavaScript. You can have an invisible identifier. You can look that up, Hangul, Hangul, white space, invisible character. Back to the algorithm. So ignore white space. Look for plus or minus. Read in the next characters until we get a non-digit character. Okay, so if we get space, minus D, ignored. We got minus sign. We got the next character until we got something that was not a digit. It was a non-digit. So all we have now is a minus. Okay, so what do we do in that case? Converts these digits into an integer. If no digits were read, the integer is 0. So what happens if we get 0, 0, 0 first? Okay, 0, 0, 3, 2 becomes 0, 3, 2. All right, so if we get 0, 0, okay, so we're in a digit, and then we get minus, well, then that's going to be a non-digit character, so then we're ignoring that. We didn't get a plus or minus here. We didn't get any white space. We didn't get any plus or minus. What's the next character? It's a 0, and a 0, and a 0. So now we've got those collapsed into zeros. Those zeros collapse into 1. We get a non-digit character, and we're done. Then we return that. If the integer is out of the signed 32-bit range, clamp it so it's in range. That means that if it's less than -2 to the power of 31, then you get 2 to the -2 to the 31. If it's greater than 2 to 31 minus 1, it's 2 to the power of 31 minus 1. All right, so here we go. What I did is I implemented a regular expression. And I got phenomenal performance out of this caching strategy, which I implemented secondarily to make it faster. All right, so the way this works is useful for LeetCode, and you will see this in older JavaScript. Nowadays, everybody wants to use JavaScript libraries and lots of classes and lots of extra delegation stuff. Not necessary. Classes are nice. They do make things readable. But this pattern is useful to know. You will see code that uses this, and here's why it uses it. And when this code is lexically parsed, we first create an identifier. We assign to that identifier the result of evaluating this expression. This is an assignment expression. So we create an identifier, then we evaluate the expression. The right-hand side of this expression is itself an expression. It is a call expression. That call expression calls an anonymous function. Okay? This anonymous function right here is called. It's an arrow function. Okay, so the outer function calls the inner outer function. This function here returns this inner function here. And this inner function then has access to all of this stuff. That's how the code is designed. That's the architecture of the code. But let's talk about the algorithm now, so that you're not going to be befuddled by this. It's not a bugbear. This is useful stuff. Okay, the reason it's useful is this inner function now has access to the outer stuff. So this is invoked once, and this inner function is the value of this a to I. So now my a toy points to this inner function. This inner function has access to things that are hidden in scope. These are essentially private static variables. They're actually private static final because they're declared with const. Cannot be modified. That's good. That locks all these things down. And it means that they're only evaluated once. We don't create a regular expression and then allow it to be garbage collected each time the myAtoy function is called. The myAtoy function is this. This is the myAtoy function, because when this code is run, it returns this and assigns it to the myAtoy variable. The algorithm is as such. We match on the pattern. If we don't get a match, we return 0, just as stated in the algorithm. If no digits were read, the integer is 0. Easy enough. The sign is the first match in that array, or the empty string. The num is the match at index 1, not the first match. The first match is index 0. Match at index 1, match index 2 is the number. And then we clamp the number. And I have a clamp function just for that. The clamp function makes it more readable. It makes this more concise. So now we have a clamp function. Clamp 32 does exactly what it says in this step here in the algorithm description. Clamps it to a 32-bit unsigned index, 32 bits on either side of 0. So negative 2 to the power of 31 or 2 to the power of 31 minus 1. And we find out, we clamp the number so that it's within that. So if the number is bigger than max 32, it's clamped to max 32. And then we take whatever is the result of that, and we clamp it to min 32. So if the number was less than min 32, and then it won out of this math.min, then it's going to lose out of this math.max in the outer call. That's really straightforward and simple. All these are cached. Now let's look at the regexp. We start with the whole group here. We start with a grouping operator that is not saved. So we're not going to save that group. We're looking for the start of the string, the caret, followed by 0 or more white space characters defined as just Unicode 0020. After that, we must find an optional plus or minus character, just one. After that, we are looking for exactly a digit, more than one or more digits. After that, we're looking for an optional end of the string. Now, if we don't get a match on this, remember, we have to have a digit in there. This must exist for the whole match, and that's going to be match 0. If we didn't have a digit in there, it would be null. The problem with array.prototype or string.prototype.match is that it can return an array, which is an object that has properties and methods, or null, which will result in reference errors if you try to get properties off of that, because null doesn't have any properties. So what we need to do is figure out if it's null. So if it's null, we say not match, that would be null. We'll return, that will be evaluate to false. and then we'll return 0. We could just as easily have written this, and that will be perfectly fine. But I chose to use this, just simpler, or more concise. If we don't have a match, return 0. And then the sign is the first match, right? Because this is grouped and saved. And if we don't have a sign, then we have the empty string. Num is the second match. Match at index 2. That's this one, because we don't have a question mark inside that regex group. Now, a question mark outside of the regex group means that group is optional. A question mark followed by a colon starting as inside of a regex group means that we don't store it. There's two different question marks, two different contexts, inside a group and outside of a group. This means it's optional. Plus or minus is optional. Digit is saved, and it is not optional. It is mandatory. So there you have it, guys. There's how to read in the instructions for LeetCode 8, string to integer. And as we can see here, we now know that if we get multiple zeros followed by a non-digit character, the result is going to be 0. And that falls right under this rule here. We see digit characters, that goes into 32, and the same thing would happen if we got 0. It's not parsed as octal, it's just 0. It's all in base 10. I hope that helps. If you see this kind of immediately invoked function expression, now you know what it is. You can come back and watch this video again if you ever encounter these weird things. Older JavaScript developers will tend to use these more because we had to use these a lot. If you're very skilled with JavaScript and you have a lot of experience, you may not be so up to speed on some of the latest things, which make these things almost obsolete, but these things are useful in this context. In actual implementation code, where I tend to work in large code bases, could be 1 to 200 to 500,000 lines of JavaScript, we probably wouldn't see as much of this unless we're dealing with legacy code. And in that case, you want to be the person who steps up and says, aha, nobody else knows what that is, but I get it. I know what the hell this is. Give me that code. I'll work on it. And that gives you a little job security. So that's what I found to be useful, is to know all these obscure little things. It's actually beneficial. It's not garbage knowledge. And so you can take that for what it's worth. Thanks for watching.